Graphically, let's actually review that really quick because we didn't do notes Friday, so it's been 4 days since we looked at this, I suppose. So let's just really quick go through a graph and talk about discontinuities and what kinds. I don't want you to pass.
Oh, sounds good. You got that. Okay, that's fine.
So write this down. And then I'm going to say list and describe any discontinuities. I'm also going to say tell where function is continuous. So this is what we did like Thursday. That was a long time ago. And then we're going to go through how to answer these questions. If I just give you an equation, you don't have a graph. Yes.
Are we going to go through like the squeeze theorem that was on Calc? Because I definitely didn't understand it.
Yeah. And then there was one with like the trig identities that I didn't remember how to do.
Yeah, go over the trig identities.
Like the last three were ones that we haven't gone over yet.
What trig identities are on there?
It was like find the limit, and then it was like it had like 1 minus cosine of x, and then sine squared.
Oh,
Like,
okay.
so we had to like manipulate that.
Okay.
So
The squeeze theorem is like, you're making it too hard if you're.
Probably.
It's like,
It doesn't help that the con video isn't really.
yeah, I don't know what Con does, but squeeze theorem is like if I know this, and this is f of x, and the limit of f of x as x approaches 0 is 1, and this is g of x, and the limit of g of x as x approaches 0 is 1. And then there's this new function called h of x, which is always in between those two. What's the limit of h of x as x approaches 0?
So
Like, it's just kind of common sense, but Con might make it more
they did
confusing.
another, yeah, they gave us the middle one and then put 2 ones there to tell, and it would change every time, and it was really confusing.
Okay. I'm not, if you had trouble with the squeeze theorem, I'm not that worried about it.
Okay.
I've literally never seen that on the AP test.
Alright.
That's not a big issue. And the trig identities, let me take a look at them and we'll see where we're at with that. So the hints were not helpful.
No.
No,
They were like,
no.
so we know this, and I was like, okay, but how?
Okay.
I feel like we do.
I know, they say we know a lot, and it's most of the case they know, and I don't know what's happening.
Okay.
It's-
It's very true.
It is.
So I'll keep that in mind. I'm not like considering a retake or whatever too. Like that's
Yeah, it was just the last three that was really.
okay.
Actually, my biggest issue was with the strategies for the flowchart strategies for functions or something. Because I'm so used to jumping steps like direct substitution that go through and listing them every one. I miss one because my brain just skips that step when I do the problem. So it's like
you say trig identity, like,
Limit found.
Basically,
Right?
then you just said.
are you saying, so like this is one that I'm thinking,
Yeah, but
that
they
one-
made it worse. It was
so that's the identity, but
That's
then
the
it'd be like 4 sine of x over 5x squared or something, and you had to figure out what that was, like that type of thing?
Less like cosine squared.
Or
of
like,
that on the
and then the limit was like pi over 2 or something.
That's not trig identities though.
I know, but like they had to.
I'll
Yeah.
take a look at
You
it.
use the pi over 2 to get indeterminate form.
Yeah.
That led you to having to use trig identity.
It wasn't, the problem wasn't on the one where you had to like match it up. Like, because you could just see that it said, this is trig identity. You could see that it was trig, and you could say we use trig identities.
Okay.
The problem was, yeah, the one where you could find the limits with the trig identities was the weird one.
So it was like what I just showed you, you had to manipulate it?
Yeah, and you had to like see when the limit like the x approaches whatever, and you had to like change it. It was through trig identities.
Alright, I'll look at it. Are we good on this? You guys done with this? We got quiet, so I guess not. I want you to do it too. Just right down. Remember, there's jump, there's removable, and then there's infinite, which is a vertical asymptote. Gus just said he got everyone fired up in here. Is that true? I told him we needed him in this class,
Oh,
and now I think it's going to his head.
You think so?
Yeah. Sure.
Yeah, I'm just like looking in that general direction.
Yeah, that was like an awkward. Also, like when I'm looking around to see like who's working, sometimes there's eye contact and like neither person was really sure what to do at that point. Okay, so if I'm just going like, left to right here, there's a discontinuity at -3, and what kind is that? That's a jump, because the roads don't meet, or the limits don't exist, the limit doesn't exist. And x equals -2 is discontinuity, and that is, you could say infinite, or you can say vertical asymptote. At x equals -1, what kind is that? -1's removable because the limit does exist and the rows come together. So the idea there is we could remove that discontinuity if we built a bridge there. But in this jump one, could I remove the discontinuity by building a bridge? No, like even if I put a bridge there, and the roads still don't meet it, now I've actually like made it not a function, so I've actually made it worse. X equals 0 is a jump, and I could not remove that because I can't. If I build a bridge, it's not going to make the roads come together. X equals 1 is removable, and the idea there is I could fix it if I just moved the bridge. So you're allowed to like move or build bridges when you're thinking about removable or not. X equals 2 is what kind? Vertical asymptote or infinite. No, that's it. So where it is continuous, you're listing like remember the parentheses and brackets? So discontinuous from negative infinity to negative 3 from negative 3 with a bracket, because that's a closed dot, to negative 2 parentheses, negative 2 to negative 1, negative 1 to 0 with a bracket, because we got a closed dot from that side. 0 to 1, 1 to 2, and then 2 to infinity. Someone last time asked, like, instead of putting 2 to infinity, could I put like 2 to 4 and 4 to infinity? There's no real reason you would do that, but just they're kind of asking, is this the same? Is this the same as this? If you go from 2 to 4 and you include the 4, and then you go from 4 to infinity, and you included the 4, is that the same as just going 2 to infinity? Yeah. It is. So technically, you could go like 2 to 4, 4 to 5, 5 to 7. I mean, you could list like every single one if you wanted. Just there's no reason you would. I'm just like pointing it out. All right. Questions on this? Okay, so let's look at if I give you an equation. Like, how do we do it from there? So algebraically, if you don't have a fraction, you don't have a discontinuity. So you need there to be or a piecewise, sorry, a fraction or a piecewise. You need the bottom to equal 0 for there to be a discontinuity or a piecewise. So we're going to do the bottom equals 0 first. So if the bottom equals 0 and the top also equals 0, that's removable. That's just a hole in your graph. The bottom equals 0 and the top does not. That's a vertical asymptote. So like if I gave you this one here, your first job is like so I'm going to say, okay, find any discontinuities. I would probably also say find any horizontal asymptotes. Are there horizontal asymptotes in this? What do I look for? I'm looking for horizontal asymptotes. I just almost said it. Oh boy. Yeah. Yeah. Thank you. Where's the higher power? They're equal, right? So what's your horizontal asymptote? One is not asymptote. Y equals 1. Horizontal asymptotes, you look for the higher power. Higher power is tied. Then you go to the coefficients, 1 over 1. So there would be a horizontal asymptote here at y equals 1. So we should probably practice that too. Okay, for discontinuities, I'm going to take the bottom, set it equal to 0. So I'm going to go x squared minus 9 equals 0. Well, there's kind of two ways you can solve this. I don't care what you use, but you have to get two answers. So you could go, okay, x plus, I'm going to factor that, x plus 3x minus 3 equals 0. And that gives me x equals negative 3, and that gives me x equals 3. Some people, I think, would take the 9 and throw it on the other side. Go, okay, x squared equals 9, and then I'm going to square root both sides. My fear there is you would do that, and go, the answer is 3, and forget that there's the positive and negative 3. And I don't care what you do, as long as you get both answers. So there's 2 times that bottom equals 0, and 3 and negative 3. So I'm going to take both of those, the 3 and the negative 3, plug it back into the top. If when I plug into the top, I also get 0, that's a removal. If when I plug that back into the top, I don't get 0, then that's a vertical asymptote. So like, let's take the x equals, I'll just write over here. X equals 3, plug it into the top. 3 squared minus 3 minus 6. What is that? 0. That means x, if I plug in x equals 3, I get 0 on the top, and I get 0 on the bottom. That is a removable discontinuity. And if you're graphing it, it's like a hole in your graph. Take negative 3, plug it in. So negative 3 squared minus negative 3 minus 6. I don't even care what you get. It's just, do you get 0, yes or no? You do not. And I don't care what the answer is. It's not 0. It would be 9. So it would be 6. So you get something else on top and 0 on the bottom. That is a vertical asymptote at x equals negative 3. And with an equation like this, you can't get a jump. To get a jump, you need a piecewise, because you need like a road from one side and a road from the other side to jump like that. So when you get an equation, the only question is it removable or vertical asymptote? Okay? Question on that one. Where'd you get this from? Why'd you, yeah?
I used to do it where I factored the top and the bottom, and then whatever crossed out.
Correct. So, kind of another way to look at it would be to go, I'm going to make the top x minus 3x plus 2. The bottom is x minus 3x plus 3. But then it just gets a little goofy with your signs. So these two would cancel, right? The x minus 3's. What's the x value that would make both of those 0? Is x equals 3. Well, that means it's removable. The ones that would have canceled, the x value that solves them is removable. And then the one, so the x equals negative 3 wouldn't cancel. And so that's your vertical asymptote. Is that what you were going to say?
Yeah.
So that's just a different way to look at it. I'm totally fine with that. I go through both ways, whatever. Just whatever makes more sense in your brain. So this one makes more sense to me, but I don't care what makes more sense to me. I care what makes more sense to you. Questions on that one or either of them? Yeah.
Is it possible to get the same outcome for both answers?
Like they're both removable?
Yes. Or they're both?
They definitely could both be vertical asymptotes. Both removable? Like at that point, your entire equation would have just canceled out. So I don't think you would see that. But vertical asymptotes for sure. And there could just be one, there could be 3, there could be like, this is just one example, right? So there could be multiples too. Other questions? Okay. Let's say x squared minus 25 over x squared minus 2x minus 15. You want me to do it or do you want to try it?
Let's try it.
Try it. Remember Test Friday. bottom equal to 0. And then I'll go through the other way also. I would factor this and go x minus 5, x plus 3. So I get x equals 5 and x equals negative 3. And I'm going to plug those back into the top. So if I plug 5 into the top, 5 squared minus 25 is 0, so that is irremovable. If I plug negative 3 into the top, I don't get 0, so it's negative 16, which means x equals negative 3 is a vertical asymptote. Or factor. Okay, x plus 5, x minus 5 equals 0, or just leave it. X plus 3, x minus 5. And then, I guess you could solve here too and go, okay, negative 3 and x equals 5. And then it's just easier to plug back in. Is that kind of like how you think about it? So if I plug 5 into the top, I can tell those are going to cancel. Or I can plug into the top and realize that that would give me 0. So it's x equals negative 3, there's nothing that would cancel with it. Or if I plug back into the top, I would not get 0. So that's a vertical asymptote. So either way you go through it, I don't care. How many had that correct? Questions on it? Try this. Wait. Sorry. Go back to this one. I mean, we're going to do it in a second. Are there any horizontal asymptotes here? Yes, where? Y equals 1. Are there any horizontal asymptotes here? Where's the higher power? On the bottom. What's that mean? I'm not going to tell you. Someone's going to have to tell me. You said it last time. Let's listen to someone else. But I appreciate that. Yeah. Horizontal asymptote of y equals 0. The higher power is on the bottom. So think about y again. If you plug in a giant number there, if you plug in infinity, what's 10 divided by a humongous number going to be really close to? It's going to be really close to 0, right? All right, try to find any discontinuities there. Everybody okay? So I'm going to take the bottom, set it equal to 0, so x squared minus 3x equals 0. I would factor out an x and go, okay, that's x minus 3 times x. So then this gives me x equals 0. This gives me x equals 3. So those are my two possibilities. There is no x on top though, so there's nothing to plug. Like if I plug 0 in for x up here, what do I get? I get 10. If I plug 3 in for x up there, I get 10. In neither case do I get 0, so those are both vertical asymptotes. Be really careful if you tried to solve this by like moving the 3x up. So I've seen this before. People will move the 3x over and then cross out an x and be like, okay, x equals 3. But when you crossed out that x, didn't you just lose the solution x equals 0? Like you just crossed off that answer. So make sure you're aware of that. How many had those two? This always screws people up for some reason. Are there any horizontal asymptotes in that one? Y equals 0. So again, think about if you plugged in infinity, what's 5 divided by infinity? Basically 0, right? So there would be a horizontal asymptote at y equals 0 because the higher power is in the bottom. Because we're talking powers of x, so there's not a power of x on top at all. And then set the bottom equal to 0. What do you get? Get x equals 0. Plug that back into the top. What do you get? Which is not 0. So that is a vertical asymptote. So if you remember what that graph looks like, that's a hyperbola. So isn't there a vertical asymptote at 0 and a horizontal asymptote at 0? But that's like to see it like looks too simple and people would be confused at it. Questions on that one? Okay. So let's look at piecewise then. So if I just said list any discontinuities or find any discontinuities. How would we go about this? What would you do first? Yeah. So we do that in the algebraic ones because we're trying to set the bottom equal to 0. Because like dividing by 0 is not a thing we can do. So we're trying to like, okay, where's that go wrong? But this isn't a fraction. This is two pieces, 2 rows. And I want to know if there's a discontinuity. So if the 2 rows come together, is there a discontinuity? There's not. If the 2 rows don't come together, is there a discontinuity? Yes, and what kind? 2. So I'm going to plug in 1 for both of those. So if I plug 1 into the top, what do I get? -1. If I plug 1 into the bottom, there's not even an x there. So if I plug 1 into the bottom, what do I get? -1. That means those 2 rows both come together at an x value of 1 and a y value of -1. So if I were to graph it, I'm not going to do like the entire graph, but it's got like 1 there and 1 there, and they meet, and there's a bridge there, and everything's nice and smooth. We come together. Are there any discontinuities? So this would be none. There are, because the roads meet. It's basically just like finding the limit. Like if I said find the limit of x equals 1, you would have to check both sides and see if they were the same. If they are the same, then you're good. There's no discontinuities. So let's do this. Let's break it down a little bit more. What's the limit as x approaches 2 from the left-hand side? 3. You said 3x? Kinda. So it's 6, right? We would plug 2 into the equation where x values are less than 2. So 6. What's the limit as I approach x, or as I approach 2 from the right-hand side? 4. Do we see that? I was just talking to Ms. Mahoney about this. It's like I don't know what to do about it, but it's really hard for me to tell if you guys understand stuff or not. Because like, no, this is what I'm saying when you do like a guess thing. Like I can't tell. So like, nod your head, give me thumbs up, do something. Like I can't tell if you guys are like, yeah, this is obvious. you're an idiot for thinking we don't know this, or what in God's name are you talking about? Like, it could be either one of those, and I'm like, I don't know which one. Thank you. All right. So, what's the limit as x approaches 2? Does not exist, because the roads don't meet, right? What's f of 2? 4. Now, remember, to be continuous, there's 3 things that have to happen. The limit has to exist, which right away we're done, right? There has to be a bridge, and then the limit has to be where the bridge is. So is this continuous at x equals 2? No. Now really, I'm just asking this question. Like, I'm just saying, where are there discontinuities? So I didn't even answer the question I'm asking. So really what I want to get at is there's a discontinuity at x equals 2. And what kind is it? It's a jump. So all of this other crap is just kind of me explaining the thought process. This is all I wanted to know when I asked that question. Like, you should understand the other stuff. But that's the only thing I really need to know. Try this. List any discontinuities and describe it. So if I plug one into the left-hand side, what do I get? 4. If I plug one into the right-hand side, what do I get? 1. So are there any discontinuities? Yes. Where is the discontinuity? At x equals 1. So that's the number we plugged in. And what kind is it? A jump. Because that's like, you got 2 rows, they're just not coming together. Okay. Questions there? I'm going to like switch it a little bit and say, find k to make the function continuous. So say it that. So remember, if it's continuous, what has to be true about the 2 rows? They have to meet, they have to come together. Which, isn't that just like a non-mathematical way of saying they have to equal each other? But they have to meet, they have to be equal, right? So all you're doing here is if I'm going to force it to be continuous, I'm going to say, okay, well that means 2k plus 1 has to equal x squared minus x. And they have to be equal at what specific x value? 3. So I'm just going to go, okay, that's 2k plus 1 equals 3 squared minus 3. I mean, now it's just algebra, which I can do, but the setup is the part I'm worried about. Does it make sense why I'm doing that? If I'm saying it's going to be continuous, that means the 2 roads have to be equal, and they have to be equal at that x value. 2k plus 1 equals 6, and k would equal 5 halves. Is that alright? You're literally the only person. Oh, I got a thumbs up and I got a head nod. Oh, we got another hand. Alright. Alright, we're getting there.
Well, science.
We're getting
Got
there.
it.
What's our?
No,
We were just talking about the
sorry,
summer
like this is so simple.
I
It
remember
makes
trying to
sense.
do something like that. but it was probably-
Wait, so you think this is simple what I'm showing you?
Yeah. Well,
Alright.
compared to
No, it's fine.
compared
Like,
to,
I just have no idea. I
When we
can't.
were doing Khan Academy summer work, I had one of those questions, and it didn't
Made no
make
And it was really hard.
That makes total sense, but I remember trying to do something like that.
Well, no one had taught you how to do it. I mean, it's different.
Yeah, but it didn't work when I thought.
So that's why I got so confused.
Okay.
I ended up getting the same question, so I'd already written down the answer, and that's how I managed to.
That's how I did it. Yeah, I did the wrong
If you just cycle through them enough,
Yeah,
Yeah.
Exactly. That's actually how I did it a lot of them.
Yes. I was just like, okay.
I'm like relieved to know that you think this is simple because I'm seriously up here going,
That makes sense.
Yeah.
I think they're lost. I can't tell.
You didn't see my head nod?
I nod my head every time
You're not,
you
like, the
ask.
best
Apparently
indicator.
not enough,
Also,
though.
written signs.
Yes.
I'm
Yes,
good.
I'm great.
We should get us signs that have like green on it or like red on it.
You mean like thumbs?
Or no, just like a green.
I'll give you a thumb,
Or-
and you can turn it up or
That
down.
would be more fun.
Yes.
No, just like
Stop
green or
sign
red
or
thing.
go sign.
I'll give you a
Yeah.
middle finger, and you can flip it off if you don't. Do you guys have any questions?
That would be fun.
Do that. Do that problem. About this problem? Avi. So I've actually toyed with the idea of having like a flipped classroom. Which have you guys ever been in a flipped classroom or had that? So that would be where I like record this video like by myself, have you guys watch it at home, and then do all your problems in here like as homework. The reason I don't do that is because then if they're like if I'm recording to a blank screen, I can't tell if people get it or not. But if you guys aren't helping me out, like I need your help. I need to know if you get it or not. That's the whole point of having a lecture like with people in the room, so you can ask questions. I can tell if we understand whether to move faster, move slower, or whatever. If we can't do that, I might as well just go to a flipped classroom.
The problem with that is
Which I'm not saying that's better or worse, but I'm just saying like you guys gotta help me. I don't know. There's no one in here that's like really outspoken and really like, oh yeah, I'm willing to talk or whatever, and that's fine. Like everyone's their own personality. I would be just like you guys in class. I would just be sitting there like, okay, whatever, sure.
I'll talk about questions, but I've understood everything, so I haven't been talking.
Okay, well then I just want to know if you know what I'm saying. I'm not like mad at anybody. I'm just trying to like I need feedback. You know, I can't teach to where I think you guys are if I don't know where you guys are. You know. Okay, so 3kx plus 1 equals x squared plus 4. Plug in 2 for x, so 3k times 2 plus 1 equals 2 squared plus 4. 6k plus 1 equals 8. And so k would equal 7 over 6. I mean, it's 7 over 6. Okay. Question?
Yes.
Well, the hand raise is good, I can tell. Yeah.
So I understand, but I just started. I already know the answer to this question. I'll ask it anyway. So all I wrote down was the 6k plus 1 equals 8, and then the k equals, because I did the rest of it in my head.
Oh, that's fine. Yeah. Yeah. You're doing the same thing as in your head.
Yeah.
What time do I have till?
27.
27. All right. So we got one more type I want to get through. This is a little tougher. giant road with a bridge.
One giant road.
This is one giant road with a bridge, right? So this isn't like a greater than less than over here. It's like this is really what's going on everywhere in the graph except for one spot. There's a hole. And then the question is, does this fill in the hole? So if I plug 4 into that top road, so what this really looks like, x squared plus 1, looks like this. And then there's a dot at 4, 5. And the question is the dot in the right spot? Does the dot fill in the hole, or did we get one of you bozos that built the bridge in the wrong spot trying to get across the river? So where should this bridge be? And what y value should the bridge be? No. 5 is where it is. Where should it be? Should be at 17. So if I'm going to close this, so how did he get 17?
4 squared.
4 squared plus 1 is 17. So this is a y value of 17. Well, the bridge is down here at 5. Is there a discontinuity?
Yes.
What kind? Removable discontinuity at x equals 4.
That makes sense.
So then, like, the opposite version of that question, I'm kind of speeding through just because of time, would be find k so that there were no discontinuities.
So then
And what would it be? It would be 17.
Oh.
Yeah.
So this is where it is. Wow. Wait.
I just felt like
Okay, so this
5 plus hours of confusion.
what happens if I like 3 equations?
There could be 7. I mean, so
Yeah.
there could be as many as you want, but you're only looking at 2 at a time. So you look at those 2, and then those 2, and then those 2, and then those 2. So only 2 can affect each other at one time.
Makes more sense.
Okay. All right. Do the homework.
Okay, Mr. Dave.
So let me just, tomorrow we'll check that. We'll probably do a little more with it just to like make sure. And then I have like practice AP questions and review stuff for tomorrow, Wednesday, Thursday. That's right. Yeah.
So this thingy, that one, the single number where it says x equals, that's where like the point is. The point is 4 or 5,
Yes.
right?
Yes.
So that's where the filled in dot is.
Yes.
And then the other one, whatever it equals when you plug in that number, is where it should, like where the hole is. So it's like,
Yes. So if the filled in dot is where the hole is, no discontinuities.